So this is a question from the Sapling for 23A. This is question 8, and the question is about if we were to treat 3-pentanone with LDA, which remember is a strong base, then react it with any of these electrophiles, what are going to be the major products. And one of the things to note here is that these electrophiles are primary, this one is secondary, this one is tertiary, and this one is also primary. And it said in the hint down here that 2 of these would undergo substitution and 2 of them would undergo elimination. So here let's look at the enolate that forms when we treat 3-pentanone with LDA. We're going to remove one of the alpha hydrogens, which is going to give us this enolate. Just a quick reminder that that enolate is resonance stabilized. That's why that alpha hydrogen is acidic. And now I can react that enolate with any primary or methyl electrophile, and I'm going to get an SN2 reaction. And there is the product of that reaction. So for A and C, those are both primary electrophiles. This tosylate is just it's a good leaving group like a halogen. And here, however, I've got secondary and I've got tertiary, and what's going to happen there is because they're so sterically hindered, they cannot do SN2 reactions. And what you're going to get is you are going to get E2 reactions. Okay, so now we've got our tertiary electrophile here, and as I said, this is too sterically hindered to undergo an SN2 reaction. The nucleophile can't get in there. So what's going to happen instead is this is going to grab one of the hydrogens because it's a strong base that's on the carbon bonded to the carbon that has the leaving group on it, and we're going to get an E2 reaction. So the product is going to be an alkene, and the other product is your protonated ketone, because that's all that happens there is just like an acid-base reaction that results in the E2 elimination. You don't have to draw that hydrogen in. I've just drawn it in for emphasis.